She looks so human.
Central London should be the last place that you'd find gorillas. But here, behind the glass in a zoo, these majestic animals offer a glimpse into our past, and perhaps a vision of our future. About 10 million years ago, her ancestors created accidentally the genetic lineage that led to modern humans. And I think it's safe to say that hasn't exactly worked out well for the gorillas. As human intelligence evolved, our impact on the world has left gorillas on the brink of extinction. It's a metaphor that researchers of artificial intelligence call the gorilla problem. It is a warning about the risks of building machines that are vastly more intelligent than us. It's about superhuman AI that could take over the world and instead threaten our existence. That warning hasn't stopped companies like Meta, Google, and OpenAI. They're trying to build computers that surpass human intelligence in every domain. They claim it will solve our most difficult problems and invent technologies that our feeble minds cannot even conceive of. I'm Professor Hannah Fry, mathematician and writer. I want to know if superintelligent AI really is just a few years away. And just as we almost killed off the gorilla, could advanced AI pose an existential threat to us? Unless you've been living under a rock, you'll know that AI is everywhere now. But it's not just about touching up photos and chatbots. You can use it for an incredible range of stuff. For preventing tax evasion, for finding cancer, for deciding what adverts to serve you. The explosion of AI tools are all examples of narrow artificial intelligence. Sophisticated algorithms that are extremely good at a specific task. But what companies like OpenAI and DeepMind are trying to do is to create something known as artificial general intelligence, a machine that will outperform humans at everything.
These sort of human-level AI systems that are very general purpose, that's always been the holy grail, really, of AI research. I think we are getting pretty close now.
The tech giants are spending billions of dollars on general AI each year, all to try and pin down and replicate something that most of us take for granted: a broad, capable, human-like intelligence. The only trouble is deciding what we actually mean by intelligence, because that proves to be quite a slippery idea to pin down. In 1921, the psychologist Vivian Henman said that intelligence was the capacity for knowledge and knowledge possessed, which does sound quite good until you realise that means that libraries should count as intelligent. Other people have suggested that intelligence is the ability to solve hard problems, which kind of works until you realise you have to define what counts as hard. Now, in fact, there isn't a single definition of intelligence which manages to encapsulate everything. However, there are still some things that we are looking for in an AI for it to be considered truly intelligent. Firstly, it should be able to learn and adapt, because we can, after all. From birth, we are gathering knowledge, we're applying what we learn from one area to another. Secondly, it should be able to reason. Now, this bit is hard. It requires a conceptual understanding of the world. And finally, an AI should interact with its environment to achieve its goals. If you suddenly landed in a foreign city, you would still know how to find water, even if it meant using a phrasebook to ask someone for help. So these are the ingredients for true intelligence. And to truly surpass our abilities, AI researchers seek to build a machine that can do all of this better than any human. Dream big, put the spoon in the pot. Start small. Worked out which one the spoon is.
There we go.
Hey! Yay! It's in! That's cool. I'm impressed. Good robot. While chatbots are impressive, language models on their own might not be enough to reach super intelligence. Sergey Levin and his PhD student Kevin Black say it might only be done once AI has been given a body, a way to physically interact with the world. Put the green spoon on the towel. Here we go. This robot might not look cutting edge, but unlike the slick robots on factory floors which follow precise choreography, this one learns every action for itself. That's basically perfect.
Yeah.
So what difference does having a body actually make then to the way that we learn?
You ask a language model to describe what happens when you drop an object, it'll say, okay, the object falls. But understanding what it really means for that object to fall, the effect it has on the state of the world, that's something becomes much more immediate when you actually experience it.
ChatGPT doesn't understand gravity, but your robot does.
Well, ChatGPT can guess what gravity is based on people's descriptions of it, but it's a reflection of a reflection. Whereas if you actually experience it, then you get it right from the source.
Do you think that AI needs to have a body?
Well, I don't know if it needs to have a body, but I know that if you have a body, you can have intelligence, because that's the one proof of existence that we have.
Put the mushroom in the silver metal bowl. Sergey's robot employs a language model to understand my instruction. It can also recognize objects because it looks through billions of pictures on the web. Next, it imagines what my instruction should look like in digital form before physically carrying out the action. Put the mushroom in the wooden bowl.
So this is actually one of the hardest possible things because we never had the wooden bowl in this lab before, so it's never seen it before. It should be able to recognize more objects that have never been in this lab before.
Can I try something?
You can.
Can I try my watch?
Yeah,
Don't worry, it's
we'll
a cheap
see.
watch.
We'll
It's
see.
okay. Go on then.
Check this out.
Put the watch on the towel.
Oh,
Here we
look
go.
at that.
Well, it figured out which object it is. It's imagining that the brown thing needs to go on the towel.
It did it.
Oh.
I mean, that's really amazing.
I did not think that would work.
But it's the fact that I can give it any command and just, it won't be thrown. I'll admit, if you look at those robot arms, they don't look like they're that impressive. But they are demonstrating a form of imagination, of prediction, a conceptual understanding of what it's manipulating. And also, it's something that is totally flexible that can be picked up and put into lots of different scenarios. These are subtle, human-like attributes that some believe are a crucial step towards an artificial general intelligence. But it's these very properties and their potential repercussions that have many people in the field worried. Just across the hall from Sergey is Professor Stuart Russell, a research pioneer who quite literally wrote the textbook on AI. He's now one of the most vocal researchers sharing concerns about the future.
If we make machines that are more powerful than us because they're more intelligent than we are, it's not going to be easy to retain power over them forever.
How might your concerns play out?
There's this idea of what's called misalignment. And this is the idea that the machine is pursuing an objective and it's not aligned with what we really want. If we're going to put a purpose into a machine, we better make sure that it's the purpose we really desire. You know, let's fix the problem of climate change. Okay, well, what causes climate change? People,
Yeah.
right? So, easy way to do that, get rid of all the people, right? Problem solved.
Why can't you just put a stop button in? Can you not just like take the plug out the wall?
We're not necessarily going to be able to do that because a sufficiently intelligent machine will already have thought of that. But you can't expect to be able to pull the plug unless the machine wants you to pull the plug.
Should we be building super intelligent machines at all?
We could just decide not to do it, but the economic incentives are too great. The amount being invested right now specifically to create superintelligent AI is in the ballpark of what the entire world spends on basic science research. And if we do create superintelligent AI, the value, you know, back of the envelope calculation is tens of quadrillions of pounds.
With these sums of money, the concern is that safety may not be the top priority.
In fact, there isn't a single high-confidence statement that they can make about these systems. Will they copy themselves onto other machines without permission? We haven't the faintest idea. Will they advise terrorists on how to build biological weapons? We don't know. right? Can you stop them? Oh, no, it's very difficult, right? And in most industries, you wouldn't accept that, right? If I want to sell a medicine, I can't say, well, it's really difficult, all these clinical trials, such a pain, can I just bypass those and sell it direct to the public? Sorry. No, come back when you've done the work. And I think that's what we have to say to the tech companies.
Are there other concerns just with artificial intelligence that's actually really good at doing stuff?
Yeah, you might wonder if AI systems are so capable that companies will use them to do pretty much everything they pay human beings to do. And if they don't, they'll go out of business. What does a world look like where machines do all the work, we become enfeebled?
Like some kids of billionaires are absolutely useless. Is that what?
Yes, in fact, we would all be kids of billionaires. And, one obvious consequence would be that we lose the incentive to learn, we lose the incentive to be independent, to achieve. In a sense, our civilization would end because it would no longer be a human civilization. To me, that's almost worse than extinction.
I mean, people have worried about this for a while, right? I mean, Turing even was concerned about this.
Oh, he was more than concerned. He was terrified. In fact, he said, it's hopeless. We should have to expect the machines to take control, is what he said.
How did he resolve it, though?
He didn't.
He just left a message for the future.
Yep. There's no solution. There's not even really an apology. It's just, this is going to happen.
And there is no shortage of people now predicting doomsday for humanity.
I think it gets smarter than us. I think we're not ready. I think we don't know what we're doing. And I think we're all going to die.
The default is just disaster, and I think most likely just human extinction.
We're just going to die. That's my fairly confident prediction.
Literally human extinction.
Of course, not everyone agrees.
This is a topic of very heated debate.
Melanie Mitchell studies AI and is interested in how closely it resembles human-like intelligence. Do you think there's an existential threat then here?
I think that there are many threats from AI, but saying that it's an existential threat is going way too far.
Why do you think that some of the doomsdayers, as sometimes they're called, why do you think that they are following this line of logic then?
It kind of gets to this projecting agency onto machines. It's saying that machines, because they have certain objectives, can start doing things that could become catastrophic if we give them that power. But that's a big if we give them that power. Are you going to give an AI sort of the decision-making power on launching nuclear strike? Let's hope not. If you give a monkey launching power over nuclear weapons, the monkey's an existential threat.
Do you think that we overestimate AI in its current form? And the follow-on to that is it harmful to do so?
People overestimate AI often. We've seen several cases where lawyers will use ChatGPT to write a legal brief, and it turns out that it's hallucinated several cases. I've in fact got an email from somebody saying, ChatGPT suggested that I read this book of yours, but I can't find it. Well, it doesn't exist. If we trust them too much, we can get into big trouble.
If we're saying that AI isn't likely to be an existential threat, it is a threat in other ways, right?
Yes, absolutely. We're seeing them already. We've seen problems with AI bias. Facial recognition software makes more mistakes on people who have darker skin color. And we've seen many arrests of people, innocent people, who are arrested because of a mistake made by a facial recognition system. Here in the US, in the election, we're seeing deep fakes of Joe Biden's voice, encouraging people not to vote. All of these things are really important to deal with right now.
Nuclear Armageddon or otherwise, there are a number of ways in which AI can be harmful. And we need to be careful in over-trusting algorithms that are capable of fooling us or making catastrophic mistakes. There's no doubt that we're at a new frontier here. I mean, there have been genuine, incredible advances and seismic changes. I think there's a lot still to come. But when it comes to a super intelligent, human-like AI that can destroy our species, I mean, I think basically it's a big old don't know. And I'm okay with that uncertainty, I think. We can mitigate against some of the potential harms, think about safety very carefully, while simultaneously maybe not losing that much sleep over something that's potentially not going to happen. I think the only thing that we can say for sure at the moment is that we have just one example of human-like intelligence, i.e. us. And AI now is definitely not a replica. It is the neurons inside our own brains and how they signal to one another that inspired the artificial neural networks driving the AI boom. If we're going to build a human-like general intelligence and beyond, could the key be a better understanding of our own mind?
One of the questions is, could you make a map of the brain so detailed that you could try to simulate it in a computer? Could you make a software simulation of it?
Neuroscientist Professor Ed Boyden is trying to understand the hardware of our intelligence by creating a digital map of the brain.
The brain is complex. Brain cells make all sorts of things, right? They make cannabinoids, molecules that act kind of like the active ingredient in marijuana, right? They make gaseous molecules like nitric oxide that diffuse in all directions. For a lot of these molecules, we really don't know what roles they play in most decisions, emotions, behaviors, and so forth.
So for everything that we know about the human brain, when it comes to understanding at the level of like individual synapses and structure, I mean, the way you're describing it is that we've barely scratched the surface.
We know very little about the circuitry of any brain, frankly. There's one worm, which has 302 neurons, where the wiring has been mapped out pretty well.
With around 100 billion neurons, the human brain might have to wait. Ed's team has started with some of the simplest of living things, including the C. elegans worm. Part of the mapping process involves probing neural circuitry using a technique called optogenetics.
We can borrow these molecules from nature that convert light to electricity, put the molecules in the brain, even in specific cells, aim light at those cells, and turn them on or off. So this is a worm where the light will activate serotonin neurons, and what you're going to see is the worm's just going to stop.
And now I'm going to turn on the light.
They just freeze completely in place.
That's one of the things that we are thinking in our group is to start with very small brains, like worms. If it works, it might reveal principles about how the brain works, but it also might pave the way to scaling up. What would it be to do the mouse brain with ballpark 100 million neurons? And then the human brain, of course, is ballpark 100 billion neurons. So, we're from worm to mouse to human.
To scale up and produce detailed neural maps, Ed is using some unusual tools.
So you know how a baby diaper works?
Unfortunately, a lot of experience with baby diapers. Ed is using a material found in diapers to overcome a fundamental problem mapping the dense web of neurons inside a brain.
For 300 years, the way you see something in biology is use a lens to make the picture bigger. What if we make the actual thing bigger? The technical term is sodium polyacrylate, and then what we can do is add water.
Oh man, no liquid left at all.
Yeah.
Sodium polyacrylate can swell up to 1,000 times its original volume.
So what we do is we chemically install that baby diaper material inside the brain. So it's not a living brain at this point, it's a preserved one. But do it just right and add water, and we can make the brain bigger.
Ed is using it to expand tiny slices of mouse brain.
All right, well, you can see the beginning already starting.
I mean, that is absolutely incredible. You can see it going already, the size of it changing.
Yeah.
It's very beautiful, isn't it? Using both expansion and a powerful microscope, Ed can see to the level of individual neurons.
This is a real piece of mouse brain tissue. Yeah, this is real data. Part of the brain involved with, amongst other things, memory. And the cells look different colors because we are color coding them. And our goal is to give every cell in the whole brain its unique color code.
Yeah, I mean, there's a lot in that image. This is a map of just a tiny fraction of a mouse's brain. Ed's goal to achieve a fully mapped human brain is still in the distant future. Do you think that we are on the path towards superintelligence in terms of constructing it artificially?
It might depend on what you define intelligence to be. Some goals of intelligence are to replicate certain functions like language. At the extreme, though, you might imagine flashes of insight, like Einstein imagining traveling along a beam of light, or sometimes people will talk about an insight coming to them in a dream, or while they're walking down the street, they're doing something else.
There's that argument that either there's something special about brains, or it is just complex computation. And if it's just complex computation, then you should be able to replicate it.
A lot of people ask me, well, a large language model, is that how the brain works? And the honest answer is, well, we don't really know, right? And maybe the brain is doing something like that, and maybe not. My intuition is that the brain works very differently, but again, since we don't have a good map of any brain, we really have no idea what the fundamental underlying mechanisms are.
I think when you hear concerns like AI is going to take over the world or it's going to destroy humanity, I think it's really easy to impart human-like characteristics on artificial intelligence. It's really easy to imagine that it has intent and understanding and cruelty, maybe. But what is really clear, talking to Ed, is that when it comes to actual biological brains, they are on a completely different level of computation, of complexity, of structure, everything. The artificial intelligence that we have now, the best stuff in the entire world, is more like a spreadsheet than it is like a C. elegans work. And I think that there's an important lesson in that.
Silicon Valley's quest to eclipse human intelligence is steeped in uncertainty. While the gorilla problem is a poignant warning for the future, we should not be distracted from today's risks, like racial bias and fake news. But perhaps, in the end, the true challenge is not the creation of super intelligent AI, but understanding the vast complexity of our own minds, a frontier we're only just beginning to explore.